So Electron is basically what drives Atom and Visual Studio and is the native application driver for Slack. It's kind of a growing strategy for making native applications. And the reason it's a growing strategy is a lot of people understand web development and not as many people understand native development. And so there's kind of been this bifurcation of different strategies to build applications. One of them is kind of going this Electron route, which we'll talk about more. Another one is using different frameworks that build things into native applications. So there's a couple different strategies for doing that. And again, we'll talk briefly about that. So those would be things like React Native or Ionic. Unity was one of the first ones that kind of did that. But anyways, the one I'm kind of excited about and why I'm presenting it is I really like using Node. I like JavaScript. I think it's relatively clean and I understand it just because I've been doing web development for a while now. Whereas I don't necessarily understand how to develop something in a native language like C++ or Swift. So anyway, so here's a list of different people that are building things in Electron. So even people like Microsoft have jumped on Electron. And I'm actually using an Electron application right now to show you all this. So Atom, but Visual Studio Code is also an Electron-based application. There's a number of other ones that you'll probably recognize on here. So WordPress, for example. Cool. So let's just talk a little bit about what Electron is, why use it, and then we'll dive into the basics of Electron. And I need to make these things a little bit bigger, so I apologize. So I'll fix that in the next iteration. So cool. So Electron is basically just a JavaScript shell for developing desktop applications. So it uses Node. It uses Chromium, which is basically a stripped out Chrome browser. Uses the V8 engine. And then Electron basically provides that backend interface. So it allows you to connect with your OS. So it basically has a bunch of different connection strategies to do, talk to different parts of your OS. And that's basically all it is. So everything that you can kind of do and why Electron was set up is basically like, hey, just take this stripped out browser, use all of your basic JavaScript strategies that you've already learned, and we'll give you a couple of hooks onto your actual machine. And so they've built it so that you can connect easily with Linux, iOS or Mac OS, and PC. So cool. So it just basically provides an easy interface for building developing. So awesome. So as I said, kind of one of the reasons I wanted to choose or chose Electron was native is kind of becoming the new web. And why? So native applications kind of give this dedicated, reproducible experience, whereas a web application, you're kind of always feeling like you're stuck in this browser land. Mobile devices have upload and download data limits. And so, the more things that you can move onto the device, the less you have to deal with that side of things. You have direct interface with lower processes, which makes these applications faster and smoother and sleeker. And you can also connect with different applications at a native level. So for example, if you wanted to remake MySQL Workbench, you could do that. Whereas you can't really do that as easily with a web application. You don't want to be able to access your own computer's file system from the web. It just ends up being a bad plan. It opens up a whole bunch of security holes that you just don't want to have open. And so if you can make this thing as something that you can download and then you can interact with your own file system and kind of know what you're interacting with, it prevents and mitigates some of those security holes. So as I mentioned before, there's some other solutions out there. Obviously, if you're a great developer, you can develop in a purely native language, right? So you could develop in C++ or Swift or Java and build your application in that language. The challenge is that people are using, and kind of the ecosystem that people are using these days is a mixed ecosystem. So, I have an Android phone, I have a Mac as my main developing computer, and everybody kind of has their own mix of different devices and things that they're preferring to use. Some people like their iPad, some people like their what is the Amazon Fire tablets or whatever. So, and you want people to have kind of a seamless experience across those different devices. So you want the kind of the native feeling of the device, but you also want to have the application that you're using on one ecosystem to kind of be mirroring what's going on a different ecosystem. So purely native development, I think, is really starting to disappear. And there's been these upcoming things, Electron being one of them, but then you have these transpiled strategies. And this is kind of why people have jumped onto TypeScript, for example. So when you write something in TypeScript, it can be transpiled into a bunch of different languages. And those languages can be, anything from C++ to JavaScript. So that's one of the reasons you put all the typecasting in TypeScript, is because that allows these other languages that are strongly typed to basically say, hey, we're going to actually make these things the right type. And some of these transpilers write some beautiful code. I mean, I got to be honest, like some of the, like, oh, well, that's how I would have written it myself. And then I look at what the transpiled code and it's like, that's a really cool way to do it. It's a much better way than I would have written myself. So they aren't necessarily bad. But the nice thing about Electron is you can kind of just use the basic web strategies that you already know. So JavaScript, HTML, and CSS. It has some other really cool things. So it allows for live updates. So if those of you who played with Atom know that there's a little thing on the bottom here that says, hey, let's make a little update every once in a while. And so you can say, oh, I want to accept that update or not accept that update. And in fact, you can even say, hey, I'm going to automatically update for you. And so there's kind of this communication between the developer and that application that they developed that gives you more control of it. Cool. So it has good package management. So it can use the NPM package management strategy. If you're a fan of the mean stack, development is very similar to the mean stack. You have a couple of other cool tools. So Devtron, which is like an advanced console and developer tool. Spectron is the testing environment that you can use for Electron. So basically, just like you would develop for Ruby or the mean stack or with Django, you're going to be wanting, or you potentially want to do test-driven development. Electron provides those tools for you. Cool. All right, so the basis of Electron. It's pretty simple, actually. So basically, you have these two processes. You have a renderer process and a main process. The main process is basically running the whole program. Think of kind of a merge between the controller and the server if you're thinking about the MVC model. And the renderer process is basically the view logic. So basically what shows up on your views. And that's kind of a simplistic way to think of Electron, but it's a really good starting point. You can obviously then spit off different things from the main process to do client or server-side logic. You could potentially talk to a database on your machine if you wanted to. You could run other types of logic, and basically you can think of those as the models in an MVC structure. Great. So you can separate the concerns, and one thing I want to point out is, and I'll talk about it again later, but Electron has really, really good documentation. But basically, you have all these different things that you can converse with the renderer side, and it's a distinct object from the main processor. So it's already kind of separating those two concerns for you. So you can do things like desktop capture, and you can use this IPC renderer, which is inter-process communication, which will communicate with your main process. And so we'll talk about some of those things in a little bit. I just threw up a list of them up here, just to kind of show you that the developers of Electron had kind of separated these concerns for you. Cool. All right, so let's get started. So it's one of the things that's cool with Electron. It's really easy to get started. So if you don't have Node, install Node. Then you just create a project folder. Do your normal npm init. Then npm install Electron pre-built. Save it into your init, and then you're pretty much good to go. It's really that easy. So we'll do that at kind of towards the end of this, and just kind of build a quick project. But it's a very simple setup process. So let's just talk about what goes in. So once you run your npm init, you'll end up with a JSON file that looks maybe something like this. Things that you might want to change. There's a main process in that init file. If you change it to whatever your main renderer is going to be, whatever file that is, some people call it index.js. If you were thinking about it purely from like a server side and really wanted to just convert things over from your mental state of being a pure web development, you couldn't even name this thing like server.js. Main.js is kind of the typical one that you see for Electron applications, but it's not the only one that you could use. And the other thing you want to add is a start script. And basically, if you've loaded the pre-built Electron version, all you add is this Electron dot, which basically says, hey, run everything in this folder that you're sitting in as an Electron file. It'll go out and hunt down this main.js file for you and get you going. So that's pretty much all you need to do for the JS file. So let's look at what the main process file will look like. And you could just run npm start here, or you could run electron dot. Either one of those will do the same thing, right? So electron dot will just run everything and hunt down the main.js file in your process. Otherwise, you can just use npm start and it will hunt down this particular file. Alternatively, you could run electron main.js. So those are all fine ways to start it. Cool. All right, so what goes into that main.js file? Basically, you're going to create windows. So this is just some code to create a window. So we generate a couple of constants. So electron is a constant. So it's basically the same sort of idea as generating or grabbing packages, because electron is just a package. And it's just requiring electron. And some of you may or may not have seen this sort of notation, but you can set with ES6. Basically, this is saying go find the electron.app property and set a new constant to an instance of that property. So if it's a class, it's a new instance of that class. Same with this browser window. So now we have available to us the constants electron, app, and browser window. And we're creating a main window variable here. Again, sorry for the small screen. I'll fix it as I said in the next variation. But basically, we're creating this variable, and why we're creating it outside as kind of a global variable is because we don't want it to get garbage collected. So this create window function, I think you can kind of figure out what it does by its name. It creates a window. So we say, hey, Electron, make ourselves a new browser window. That browser window, we can give it a height and a width, so we can put inline styling on it. We could give it a background color, do all sorts of fun things. Then we say, hey, what do we actually want to load into that? We want to load some sort of index.html file or some sort of HTML file into this window. And basically that's going to say, hey, this is all the styling that's going to go into and all the information that's going to go into that window. And once you're at that point, you're basically just running this thing like it's normal web development. Electron has this nice convenient aspect of it, which is you can preload the developer tools. So while you're developing, you can automatically set your developer tools up and have it open up as a piece of it. And then the last thing is just when you close that window, what happens? Cool. So that's part of the main function. But again, so that's kind of the controller side of this main.js file. So basically you're saying, hey, I'm going to load these different views, right? But the other aspect of the main.js file is the server side. And so you basically have to say, hey, Electron, I'm ready to do stuff. So this next slide is going to be basically talking about that. So if you think about it as a server, you basically have to say, hey, this application is ready to go. Let's run a function. And so the callback that I'm passing in is just that create window one, but we could pass in other callbacks if we wanted to. So it runs that callback, and in this case, it creates that window. So when everything's ready, creates the window. All right. When all the windows are closed, we run this function, and if it's any other system than a Mac, it quits it. Macs will wait to actually have you hard quit in this particular instance. Cool. And that's pretty much what that code's doing. It's basically saying, hey, as I said, if you're thinking about this thing as a server, it's just turning it on. You know, you can put console logs in here and say, hey, my server's on, or my Electron application's on at this point. So cool. All right. So we've got a window now. What do we want to do with that window? Well, we've loaded an index page potentially. So here's basically just a general JavaScript file. And notice that we're using this weird terminology. Instead of doing script source equals render.js, because this is all local and all running on Node, we can use all the Node specific ones, and it makes the language, I think, a little bit cleaner. And I think we're going to be seeing this in ES6 and ES7 as it moves forward. Is that people will stop using script source and start using require a lot more, or import even. So Electron doesn't support import, surprisingly, or not yet. All right. So basically, we're saying, hey, go require this renderer file. And that renderer file, remember, is a separate concern. And so basically, this is still a piece of Electron, but it's a piece of Electron that's specific to loading views. So basically what we say is, hey, we can go and create this thing. You don't have to load this thing. You know, you could have a window that pops up and just has normal HTML, and that's all it is. But if you have a renderer file that you want to use, you can then load it, and then you can do communication back and forth between your window and your operating system. And the way that Electron does that is it uses this product called IPC renderer. And you can think of IPC renderer as kind of like sockets. So it has a very similar notation to sockets. So you send a message. That message has a key, basically. Your main process will have a listener that listens for that key and then runs a function. And then you could pass that data over as or with that thing. So that data could be a string. It could be a callback. So same exact sort of setup as sockets. I threw up another couple things in here. So this menu, basically this remote says, hey, go to Electron and get remote and allow us to access a lot of the main processes in our view. And so this is a way to allow you to manage things like the taskbar up here. So you can start modifying what shows up in your application when your application is open. So in this case, Atom has made all these different things. So when you open up an Atom application, you'll show these different views, and these are all these basically what this submenu stuff is doing right here. And so we'll see that happen in just a second. So once we start to build an application. All right, so here's the inter-process communicator, just kind of in two chunks. So again, on the renderer side, you send something. On the main side, you listen for something, and you can do the reverse. So you can do exactly the same sort of conversation that you have with sockets. You can say, hey, I've got a listener on this side, I've got a listener on that side. I'm just going to pass these information back and forth, and kind of make it doesn't open up a socket, so it's not analogous in that sense. But in terms of how you write the code, it's analogous. So in this particular case, like if I pass an intro, basically I told my main process to go and make a new sub window and open that window up with a width of 300 and height of 300 and pass in this intro.html file. So simple as that. Cool. So the other cool thing that we kind of mentioned, Electron works totally fine with NPM. So if you love certain NPM packages that you want to use, for example, this is some code that's interacting with the Mongoose database or with Mongoose. You can just say, hey, let's make a constant. Well, we'll npm install Mongoose and save it into our dependencies. And then once you start Mongot up, just like you would normally with a server situation, you can then say, hey, let's make a Mongoose instance. And then we can start playing with FS because it's Node still. We can play with Path. We can do everything that you would have done in Mongoose. So you could, in theory, be hitting a local database and be like, okay, I'm turning this local database off, and my application is basically using stuff from that local database. So I think it's pretty cool. People have played with that. So I mentioned this process or a Node application, or sorry, an Electron application wagon, which I think is going to eventually become kind of a replacement for MySQL Workbench. In my spare time, I've been actually working on a MySQL Workbench for Mongoose using Electron. It hasn't gotten very far, so I don't want to show it to you guys. So, but it's going to be, hopefully it'll be cool. So it'll be able to basically do a lot of the Mongoose queries and be able to test things instead of using the shell. So awesome. All right. So the other weird thing about Electron is when you're accessing JavaScript libraries, and I think a lot of people are going to run into this problem if you jump in, you really need to be careful about how you set up your variables, and you have to set those window variables specifically. And so in this case, I'm going to try to use jQuery, for example, or if I was using Angular or React. I couldn't just say require Angular, React, or jQuery. You actually have to set the variable for that window specifically. And so basically what I'm saying here is set both $sign and jQuery to the return of my jQuery JS file. All right, so quick recap, and then we'll build something. So first of all, the goal of this presentation was basically just to kind of give you a flavor of Electron. I think it's really cool. It's, if you like JavaScript, it's a really great tool to build these kind of really sleek applications or potentially sleek applications. The documentation is really great. And then let's just go ahead and build something just to kind of get you guys a sense of what Electrons like to build with. So that'll be the next chunk here. So I'm going to make just a whole new file here, and we're just going to start from the beginning. So just making a new directory. I'm going to make this a little bit bigger so we can actually see stuff. Electron fun. All right, so cd electron fun. I don't know why I always talk through like whatever I'm typing. I'm just kind of weird that way. So npm install or npm init -y. Cool. And then npm install electron rebuilt. And it's not a small file. It's not a small thing, but whatever. It takes a little bit of time to load itself on up. Cool. So right now it's main, my JSON files index.js. I'm going to change that to main.js in just a second. So let's get Atom up and running. Change a few settings on here. And the cool thing is, just like you can do this with Atom, in theory, you can set up your Electron applications to be editable with less or Sass or whatever. And set up hotkeys and all sorts of fun stuff. Cool. Ah. All right. So we're going to make a new file, main.js. I don't want to have you guys watching me type a bunch of stuff. So I'm just basically added that load windows side of things. And then I'm going to add the rest of that Electron code as well. And it's going to turn on our function. So cool. So we can put a console log in our create window just to show what happens. Hello world. This is our window. Cool. All right. So right now, all we're doing is saying, when we turn on Electron, we're going to make this browser window. We're going to go and find, from our local directory, find that path and get index.html. So obviously, we need to make a new file for index.html. And we're going to keep it simple for now and make it just hello world. Cool. All right, let's go ahead and check that out. So oops, we didn't change something, right? So I forgot to change my JSON file. So let's change this to main.js. And let's make our start script. Start. And that's going to be electron dot. And it's part of an object, so that should be good. Cool. I tried to say it's part of a dictionary, but too much. There we go. So we have our first application. Let's go ahead and tweak it a little bit more. So as I said, one of the cool things, I didn't say it, but one of the cool things about Electron is that because it's a stripped out Chrome browser, you get access to all the Chrome developer tools as well. And so everything that you could kind of do with a normal development process in terms of web development, you can kind of do with Electron as well. So it's pretty sweet in that sense. So you can do look at the console logs. Now, again, just like with the main stack, there's the separation of concerns. So if we loaded a renderer.js file onto this thing, those console logs would be occurring here. Whereas if we look at our terminal, when we loaded this window, it should have console logged hello world. And so there's the hello world. This is our window console log on our server. All right. So far, so good. Let's go ahead and play with some more things. So let's talk about using that IPC rendering strategy. So here's an on over here. So in our index.html, let's make ourselves a script or a script. And let's require, and it doesn't have to be renderer.js, but let's keep it simple for now. And again, let's go for, So what I've done here is basically said, hey, let's still use Electron over on our renderer side. Let's create a remote so we can access other pieces of Electron. Let's go ahead and set up a menu. And that menu item is going to be part of this remote. And we're also going to have access to IPC renderer. We're not going to use IPC renderer just yet, so I'm going to console log that out, or comment that out for now. And let's go ahead and restart our Electron application. And so remember before when we had Electron up and running, we have all of these different options on our submenus. Now I've changed those things by basically saying, hey, let's customize our submenus. Let me figure out which atom I'm actually looking at. And I said, let's just create one called Electron. And inside of that submenu, let's just have an About Electron dropdown. So that's all I've done. So let's go see what that looks like when we actually run it. So I'm going to turn off Electron, turn it back on. And so now, when we look at our Electron, we now have this new part of it about Electron. And if we click on that, oh, this is not the right one. Oh, sorry, I didn't create my renderer.js. I probably called it render.js or something. So let's go ahead and check that out. So there's renderer.js, index.html, renderer.js. Yes. Sorry about that. And we can see the console didn't fire correctly before we had an error. Now we don't. So now we have this About Electron. That's still not quite firing correctly. Sorry. Never had this happen before. Sorry. That's just a joke from yesterday. All right. Script source, HTML. Let's figure that out really quickly here. That looks right. Let's put a console log in our renderer. Oh, no, we didn't do. We didn't actually tell it to build this menu, so that's part of it. So I think it loaded fine. So if we put a console log in here, like loaded our renderer, that's perfect. But we didn't actually say use this menu. We've created this variable. We haven't actually said to use that menu yet. And so we have to say, hey, we need to go and update those actual pieces. So that's part of the menu object. So and we'll do that in a second. Cool. So let's just see that that thing's actually up and running. So now we should see the console log firing over here. There's our loaded our renderer. So it's loading fine. As I said, I just didn't do everything that we needed to on it. So let me look at that code really quick. That's going to be in renderer. And what we didn't do is this menu set application menu. All right. So go back over here. So menu, set application menu. And we're going to pass in this menu constant. Cool. So now when we rerun this thing, we should see that new change. There we see this Electron. This is About Electron. And we click it, we should see the click firing in our console. Cool. All right, so let's go ahead and play around and just show one more thing with the IPC stuff. I think in terms of time, I'm going to stop it at that point right after we show this kind of socket-like behavior. But obviously, we could have loaded jQuery. Before I started this demo, I basically made a little Pokemon thing that would load Pokemon into new windows as you click them. I think we're not going to have enough time to do that, but it's really simple. I mean, you just basically make a call to the Pokemon API and use the IPC renderer to create new windows that do the behaviors that you want. So you basically pass that data in for whatever click you've got. All right, so let's go ahead and look at this. So we're going to add this line back in. And we're just going to pass in a key of hello. I know it's not very exciting. And then on our main, we're going to listen for that hello. So main.js. All right. So we have IPC. Oh, we don't have it yet. So we need to make it, right? So we need to have a constant from Electron, and it's going to be IPC main equals Electron. So we've now created a new variable, IPC main, that we can then use. So, and then on, quote, hello. And then we have a function that we can call. So this is the callback that we can run. Again, you could have passed in a function from our renderer had we wanted to. And we could pass in, and it takes 2 parameters. So I guess this is one thing that's different than a socket. Sockets just take the data as the primary thing, but IPC catch an event first and then the data. So if we console log data here, this should be whatever we passed over. So in our renderer.js, we passed over this data here. So we should see a console log on our server side of this sum data. Was that? Oh, did I just put in a string? Yeah. Oh yeah, meant to put the data variable. All right, so let's see that happen. And then what we can do is we could potentially make ourselves a new window if we wanted to and say, and we're not going to do that, but you could say something like let temp window equal new browser window. I guess we're going to do it because. All right, and then we load something with our temp window. And we could, let's cancel that. And we could just make this like info.html, make ourselves an info HTML over here. All right, and then we do other stuff over here. So let's just make an h1. Out Electron, and then make a p tag. It's awesome. Right. So now at this point, let's see what happens. I think we've got everything in here. So there's our usual thing. There's our start of a renderer. Cruise over to About Electron, click on this, and there's our new window that we just popped up. And then the last thing that I want to show is that that data should have printed out over here, and there's that data that's getting printed out. So again, you could have passed in a callback through there and run it. You could have passed that callback in directly and had it run. So cool. I think that's it. Any questions? I'm not an expert in Electron. I've got to admit. I think it's super cool, but I haven't had as much time as I would like to play around with it. But it's definitely fun.
This might seem like a huge question that's probably might not be easily answered, but like, how do you think Slack is set up using Electron? Like, how is it hanging on to all that data, all the messages going back and forth and stuff?
Yeah, so I think it's pretty straightforward. I think Slack, the website, hits a database that probably has cores turned off so that it can be hit from other locations. The downloaded application, I think, is exactly the same front end or a very, very close facsimile of that front end. So they probably just grabbed it and been like, okay, we built Slack for the web, probably grabbed that front end, pulled it over as their front end MVC architecture, and then basically had URL hits that are coming off of that same application, hitting that same database. So it's hitting a remote database rather than a local database. And that's probably it. So it's probably super simple. And it's easy to hit outside sources. So you know, we could, and let's just extend this a little bit. So let's just add Ajax to our index.html. So we're going to go into our renderer, and we're going to add some Ajax availability here and an Ajax call. So we're going to add JavaScript or jQuery, because I think Ajax is easier to write in jQuery than it is in vanilla JavaScript, so I don't have to make all those curl calls. So Electron library. So now we have, well, we have to Bower install jQuery. That's easy. Let's go ahead and do that. Blah, blah, blah. Or install jQuery. And didn't save it, but whatever, it doesn't matter for this. Cool. All right, so now we have jQuery. And so so remember, this is the basically the view logic, right? So this renderer, we could have renamed something else, but it's the view logic for that index.html page. So this index.html page. And so on that index.html page, we could have maybe something like a button. And we could say, on click, let's do something with that button. And when we click it, why don't we make an AJAX call? And that AJAX call is going to go to a URL. And so this is, I think, exactly what Slack's doing. So it's going to say, hey, let's go to a URL of, let's look at the Pokemon one. I don't remember what it is, but even though I said we weren't going to have time to do this, whatever, we're going to do it anyways. Pokemon API. So grab this guy, Pokemon 1. Right, and so there's the URL. Method is going to be a get. Success is going to take some data as a function. And we're just going to console log that data for now. If it were Slack, we'd be pushing that to different parts of our page, right? So, and we could even do that. We'd say append, and we could append. Let's just make a p tag in here. Not very exciting. From it's not. Oh, there. That's off. Okay. So now when we get the stuff back from this Pokemon API, let's console log the data, which we did, and then we also appended, got some data from server. We don't have a button yet on our index.html, so let's make a button. Me for Pokemon info. So this is still using that same renderer.js file, and we now just have our JavaScript or jQuery running in here. And obviously, you could make this a separate file and access it and pull it into your renderer as well. So let's go ahead and take a look. All right, so there's our Pokemon. And there's the Bulbasaur, and there's got some data from our server. So again, as long as you have access to that outside server, then you should be able to make local apps that actually query outside data. So if you wanted to make a cool app that basically said, hey, go and get the weather that's currently and have it sitting up in my corner every once in a while, you can do that. And you can adjust, like with the taskbar, with tasks, you can adjust what shows up here, just like Dropbox, and be annoying and always show up and never be able to get rid of it. So as I said, there's a lot of cool APIs. And I think the documentation is really, really good for Atom, right, and Electron, sorry. Cool. Other questions?
Do people generally pull any particular JavaScript libraries to use on top of Electron? Like, is jQuery pretty common, or are people using other?
People are using everything, yeah. So there's definitely Angular and React are kind of the big ones still. So or just jQuery. So yeah. So I think most people that are playing with Electron, I think at this point, so this version of Electron just came out in May. So May 11th, I believe. It's been around for about 2 years. So basically, right after Atom came out, they're like, this is kind of cool. We like how we stripped out the shell and gave us all these access points to the file system. And then it was originally, how Atom started was originally Mac specific. And they started adding on the hooks, and basically kind of the same way that jQuery itself says, hey, what kind of browser are you using? Electron is saying, hey, what kind of OS are you using? And then it says, okay, well, if you're using that OS, this is the hook that I'm going to be using. So it does a quick test on what type of OS you're doing. I assume. I haven't looked at the back end. So then at this point, so basically evolved up until they were pretty confident and happy with how it behaved on all different operating systems, and that was the newest release with the 1.0 release. So, but yes, so I think most people that are using Electron are people that are love JavaScript, and people that love JavaScript are generally playing with the newer libraries. So. Yeah, so it's cool. One thing I should say is that unless you're really, really good, it's easy to write not super efficient code. And so even though like an example would be Visual Studio Code and Atom are both written in this Atom shell, in this Electron shell, Atom's significantly slower. And it's one of the reasons is that Atom's being built by not amateur developers, but by a group. It's definitely a community-based developing system versus Visual Studio Code, which was like, okay, so Microsoft's going to say, hey, we're going to build this thing to our specifications, maybe limit some things that it can do, but in the process of limiting those things, it runs much quicker. So there are trade-offs. So there's, the more you open things up, the more chance that you have to catch, you have to listen for more things, and it potentially slows things down. So something to be aware of. Cool. Other thoughts, questions, comments? Shall I turn the video off?